Well, this is a very important place. It is a historic place, as it has been rightly narrated by our engineer Sivanyanam sir. It's a historic building, historic area. Because IEI, we know that Institute of Engineering, it has brought several marvels in this country. It's a century or beyond century old institution. And coming to Neyveli Center or Neyveli chapter or whatever we call it as. Come Rajmohan. So another great. I was just looking that some minds presence is not there. At the right time, minds people will visit. So that is how he has done it. So Rajmohan has come. So this Neyveli Center, if you see that, it started in 1967. And it is much older than many of you present here in this hall. And if you just to go through the laurels of this institution, at the moment when I have taken over, when I just listened something and then I have gone through the files, it has brought transformation in this Neyveli. I do not know all these people by seeing them. I got a little, embarrassed rather. So many things is it possible. It is not that just some programs or something they have brought, some changes they have brought. They have lighted the lives of many people. This is the center which has produced the highest number of AMIC during that period. And not that several people have occupied very high positions because of this center. At that center, from that position, it has been raised back. It has bounced back. I can say it is a renaissance. I can say that last 4 or 5 years, what I am seeing here, it is a renaissance. And I have seen that the way the committee members have taken active participation and then they have brought the things back online, especially bringing so many students into this forum and increasing the number of programs and then activities, some competitions and then celebration of several days. I am damn sure that another chapter is waiting for this Neyveli to prove its point. I am damn sure with the present committee, the youngsters who have taken over. Well, today's topic is rehabilitation and retrofitting. It is something, as it has been rightly said by our former ED, there is a thin line of difference. I am not an expert, but let me accept that. Except some activities on the power plant area, I am really not an expert, but have some ideas because of its importance. Gone through some papers and then gone through some research works and then I could get some ideas and then I thought that it is appropriate to exchange all those things because a lot of youngsters are sitting here. Rehabilitation, in simple term, it is synonym to maintenance. Very, very closely it is synonym to maintenance. Rehabilitation involves observation, some routine maintenance, some preventive maintenance, some condition monitoring and replacement as and when required. So all these things are coming under rehabilitation. Coming to the retrofitting, it is totally different. It is very different from the rehabilitation in a sense that, but of course we use interchangeably rehabilitation and retrofitting. But the thin line of change is that the retrofitting is at least an iota of increase or improvement or difference should be there from the original purpose. Whatever the purpose for which the structure or the equipment or it is designed, if you try to bring something extra, it may be an extra addition, it may be a functional improvement, it may be a better safety version, or it may be higher load bearing, or it may be higher resilience, or it may be a higher protective coating. Whatever it is, if you are able to make a small change or small improvement from the design, then the word changes to retrofit. So this is the thin line of difference, and of course when we discuss, let us see that how far we are able to understand this term better. Having understood what is retrofitting and then what is rehabilitation, let us try to understand that when since it is there, why it is so important that now we all have to discuss this and then how long the subject is there. What is this rehabilitation? What is this retrofitting? Whether it is a new thing, 5 years before it has come, or it is a century old, or it is 1,000-year old, or 2 years old, 1 year old, or some techniques are new. What is it in that? So that is the next question obviously everybody will ask. For that I have to take you to the real civil engineering or the real point at which the thinking of building has come. If you see that anthropology or Scientology, if we just go through that, how long the subject has been there, or how long this anthropology, how long this mankind has been there on the globe, if we just try to understand, there are several theories are given. Some theories suggest it is millions years, some theories suggest much more than that, some theories suggest few lakh years. But one scientific evidence very clearly indicates, based on the carbon dating and some of the skeleton what is available, scientifically it is proven very clearly that mankind or man or woman, they have been present on this globe for more than 1,65,000 years ago. So that means it is very firm. 1,65,000 years we have been here. Beyond that, how much nobody knows. I don't want to guess. I want a very scientific fact when we are discussing with the students especially. So we have been there for more than 1,65,000 years, and all through these years, for your information, the man or the woman or the mankind or the person, whatever you call it as, we have been living without any houses for most of the time. We chose the path of nomadic life. We were not having permanent structure, we were not having anything for a very long time. And something like 15,000 to 20,000 years before, something around 15,000 to 17,000, very clear evidences indicate that first time a person, a man or woman again, thought that there should be a small shelter for me. There should be a small shelter, means something should be there to protect me from sun and rain. Something should be there to protect me from animals. This is the first thinking, but it is not a simple thinking. A man who has been there for close to millions of years, some 10 or 15,000 years before, he thought that there should be a small shelter. It may be a small coverage with the stones, but he thought that there should be a shelter required for me to protect me from sun and rain, and then to protect me from the animal. And this thinking is the starting point of civilization. The great civilization what we are talking about started from this very idea of I need a place to live. I need a place to protect myself. It is not a simple thinking. The entire thing, whatever we are talking about. And during this analysis, I thought that in the other side, on the lighter side, whatever we are discussing today, this 3 BHK, service apartment, efficient apartment, individual house, row house, efficient, inefficient, or service, whatever you call it as, farmhouse, all these things have started some 15,000 years before because of one person thought that there should be something required around us. But for me, if you just think on the other side, it is not just the starting of the civilization. It is the birth of civil engineering at that moment. The birth of civil engineering started with the very first idea that I need something to protect me, I need a building. Because from this only, subsequently, there was lot of settlements. And subsequently there are infrastructures, there are some ceremonial buildings, there are some big mandirs, temples, there are domes, there are some water bodies, there are some reservoirs. All these things have started from this idea, and we can keep discussing. It is from 10,000 years before or 10,300 years before BC, the Mesopotamia, the cradle of civilization of the world, what people say. It is because of the idea of that we should have a building. The very first thing, they have started only with a building. And subsequently we can keep telling that Mohenjo-daro and Harappa or these things, or you can even say that Adiramapattinam or Keeladi or name anything, or Sangam age, or the built of several temples, or Begradeshwara temple or Kallanai. You name all these things. It all started some 15,000 years before with the simple idea that a building is required, right? And this is the birth of, as I said, civil engineering. And then civil engineering is the topmost or the first engineering which has come into this world. I don't have any doubt in this. That is why when I interact with the civil engineers, always I am little humble. Because they are the people those have started. We all have followed with a different engineering. The civil engineering has started, and then if you see that the college wise also, 1707 the first college was for civil engineering in the Czech Republic. 1794 our Guindy Engineering College, that is the first college in the India, that is also for the civil engineers. And the next college, Thomas Civil Engineering College, that is IIT Roorkee now, that is also for the civil engineers. So civil engineering, either with respect to the engineering or the birth or civilization or whatever you call it as, that is the starting point. So it is aptly that our civil engineering department is arranging this. I am very happy. For this I have just referred to 2 books, or 2 big books or volumes you can say. The 2 books are, one is the ancient architects by Mr. Hugh Plummer. It is brought out in 18th century. And it covers everything. He is an American, but of course he has covered everything. It is a vast book, a fantastic book. And another one book is by our Dr. Neelakanta Sastri, 1957. It was brought out in Chennai. He is a great historian or architect or whatever you can say. These two books you can see, and then of course some of the poems written by our poets. So that also describes something about it. So these three are my references, because whatever I am giving it, everything is with respect to this. Because this person, Hugh Plummer, whomsoever, whatever I am telling, he has referred so many research papers, at least by different places I could count minimum 121. We could count 121. How many more are there, we do not know, because during that time that the concept of the bibliography, references and all were not complete. So 121, curiously just I have gone through some of the papers, and from there we could come to some conclusion. So maybe experts can further elaborate during their discussion. The first and foremost fact with respect to this rehabilitation and the retrofitting. The day the concept of building, the day civil engineering has started, the retrofitting or the rehabilitation also has started on the very same day. Take it from me. There are very clear evidences. These research papers, whatever I am telling, that also talks about rehabilitation. So that means from the beginning it is there. And not only that, very clearly there is another evidence for us. Especially for our Tamils, we have lot of evidences. There are several dynasties which lived for some 500, 600 years. There are several dynasties, you can see that. And these poets, when they are writing about the king or anything, they will start with explaining the structures. You can see that even if somebody wants to praise Sivaperuman, they will first talk about the buildings, or his Kailayam, or his Mandir, or temple, or whatever it is. They will start from there, and then only they will come to that. And all these poems, these buildings are always explained or expressed very nicely. That means there is no fault or there is no defect or nothing is there. That is all there only in the later period. So that very clearly indicates that something had been there, some mechanism had been there to maintain these buildings. At the moment when you say that there is a mechanism to maintain these buildings, definitely there will be a rehabilitation. Next message. If it had done from the beginning, whether people have applied it or not. Yes, evidences very clearly say that there have been technologies and techniques. People have been applying it from the beginning. From the olden days, very clearly this research paper indicate that they have applied it. To what extent it is appropriate, we do not know, but they have applied it. The third one, this is the most important thing. The paper or the things very clearly indicates that all the structures, what has been built, which needs some rehabilitation, or which needs to be attended, or which needs maintenance. That means, you built anything, we cannot say that I have built it, I can forget it. There is nothing in this world, there is no structure in this world that is you can build and then forget it. Maybe you can ask, there are some open structures are there, some rocks are there in that they have encrypted whether it will come or not. I am not an expert, but very clearly we can say that from the evidences that any structure you build, unless only there is a maintenance, unless only there is a follow-up, it will not last long. Or maybe it will die down very fast. Or whatever duration we thought, it may not serve for that. Or on the other way, I will put it this way. If you are building some structure for some 100 years without any maintenance, if you start maintaining it, it will exceed its life. This is the very fact. So these three facts are very important. From the research papers, these three things I have got. Now let me come to the next question. Whatever that they have given that organizers, I am going in the same way. Why is it required? It is a very funny question. Why it is required rehabilitation? It is well explained by my predecessors, and then all of you know that to extend the life in a simple way we can tell. Somebody can say that to cut the cost, to somebody say that economically it is better and all those things. But let me just take you through one small example. After understanding that, after going through that example, you will understand the real meaning of why it is required. This story is about the Sibu Ample temple, which is there in Egypt. We all know that river, and in the river bed, this temple was there, this Nile river. In the banks of this river, this is there. And in 1960s or 1950s, they thought that there should be a dam for two purposes. One is because this Nile is causing really a havoc and it is to be controlled. And the second one is, it is to be used for some irrigation and other purposes. But the point is, they have studied well and then they have identified a place where the dam can come. And they have named it also, if I remember correct, some high dam, that Arivumani high dam or something like that. And when they decided that, okay, the dam will come this place, this is the most suitable place, everything is fine, it will immerse so much of place, but only one worry for them is that there is some Sibu Amble temple, like that one temple was there. The temple is the 3,600-year-old temple, a beautiful temple. But the temple will get immersed. This is the problem. They looked for some other solutions and then locating the dam somewhere else, but nothing worked actually, because it is not possible, because that is the most suitable place, economically, beneficially, for hundreds of years it has to come. So, they looked for UNESCO. They asked UNESCO, we are helpless. We want to build it, but this structure, 3,600-year-old temple, it will get immersed. UNESCO also doesn't have any solution immediately. They have thrown open the question to entire world. They have sent this question to entire world. Some 36 countries have participated in this discussion. 36 countries. Just imagine, in the 50s, 36 countries have participated in the discussion. Out of all, finally one UK architect had come out with a very beautiful solution. And that solution is, I am not even able to imagine now, the temple was sectionalized into some 1,000 pieces. That one temple was split into close to 1,000 pieces, and all these 1,000 pieces were cut, and this was shifted, and it was lifted by about some 65 meters, and then the temple was established. And in 1960, the dam was also built. The temple got additional beauty. In the banks of this river, the temple is standing tall, and then the people were not having words to express. And the people, those who have participated in making this or shifting this temple, they said that we are really honored to see that. For that, some 2-line reply that was given by the Egypt people on behalf of everyone. It is not that you have relocated the temple. It is not that you have brought the temple from this place to this place. You have given a life to our culture. This is what is the word which people have used. You have brought the light to our culture. You have given the value to our belief. You have given a respect to our ancestors. You have seen that the history is continuing. These are all the 4 lines they have written. Just imagine how important it is. Rehabilitating a structure of architectural importance of say 3,000 years or 1,000 years or 2,000 years. How important it is, you just see that. This is the first reason. It is not that just we are rehabilitating some structure and then bringing. It is the value you are bringing, you are continuing the history. This is the first message. The second message is very clear. Economic conditions. Economic conditions, I can give hundreds of examples. Only one example I would like to give, and then I would like to slightly take a detour because our ED sir has prompted me to talk something about LED. Because having said that, ED, as a director, if I don't answer, I will former director. Probably he may file a case tomorrow. This economic point, whatever I said, just imagine for a while this Kallanai, which is serving us for 2,000 years. 2,000 years, this Kallanai is irrigating 3 districts. The 3 districts flourished only because of that Kallanai. Just imagine that you'll have to rebuild it. How many years it will take? Where you will do? How will you do? During that time, what you will do? And what is the cost? Whether it will serve the same number of years? Nothing is clear. And this, even now, things are not imaginable because some of the drawings we referred and then we have seen that things are not at all clear how they have imagined that this dam will come for more than 2,000 years, because this is the first dam in India and this is the longest serving dam in the entire world. In the entire world, as on today, this is the longest serving dam. And in the entire world, this is the 3rd dam. Such a valuable dam, if you just think that I want to rebuild it, I am ready to spend the money, but who will do that, and then during these interruption, what will happen? Let us suppose it is taking some 6 or 7 years. What will happen during that time? It's not clear. So, economically, if you see that, I don't have words to express that, this rehabilitation and retrofitting, how far it has helped us. As I said that I will slightly take a detour of this rehabilitation and then retrofitting of plants or industries or some of the structures or some of the facilities or factories. I just thought, yeah, while let us go through that nuclear industry. In 1969, Tarapur Atomic Power Station, this was built with the support of USA, and originally the design life of this plant is 25 years. That means 69 means 79, 89, 94, the life of the plant is over. And it is producing something like 220 megawatt at that time. Just imagine in 1969, 220 into 2 units have come with some cost. And now the entire capital is recovered after 25 years. And after that, whatever you are getting is, there is no capital component at all. Very cheap power, the cheapest power in India that plant is able to give. And this rehabilitation and then retrofitting, as I said, from the beginning these techniques were followed. Whenever any safety upgradation is there, this plant will be upgraded. Whenever any rehabilitation is required, we have a very good elaborate NDT techniques, and all these things are applied. And by continuing all these things, I am happy to tell you that this plant, even after 57 years, it is operating even today. This is the oldest serving nuclear power plant in the entire world. So we have a nuclear plant of 56 years. The beauty is that it is designed for 25 years. And it is operating on par with the plant which is built just last year. This is the speciality, this is the beauty, this is the outcome of retrofitting and the rehabilitation. People should understand. It is not that we are talking about something on some archaeological structures. This involves a very elaborate arrangements. It is not that simple thing. It is a rebound hammer test, or you tell a pH test, or conductivity test, or ultrasonic test. Several tests are there on the civil front, like that on the mechanical front it is there. All these things have been done. Of course, every time some 5 to 10% of the money was spent in a period of every 10 years, and these plants are even operating. The latest information is that it will operate for at least another 10 years. So this is what is the thing. And it is not only that one exceptional case of Tarapur plant, our Madras Atomic Power Station, which is built in 83 and 85, 2 units. It is also designed for 25 years, but even today one of the units is operating. And not only that, our 2 units I am talking about, throughout the world as on today, 432 reactors are operating, out of which 60% of the reactors, more than 260 reactors have completed its design life. But all these plants are operating with a capacity factor of 87.5%. Just imagine, 87.5% is the highest capacity factor, and it is delivering power. And imagine for a while, these plants, if I want to replace today, because I don't want rehabilitation, retrofitting, all these things, all this nonsense I don't want to do, I want that, let us replace it. 3 lakh megawatt units, if you want to replace. As on today, the average cost is about some 25 to 30 crore per megawatt. Even you assume that some 2 lakh if you want to build. Just to calculate the cost. It is something like 75 lakh crores you will have to spend. On nuclear industry alone, just one example is this rehabilitation and retrofitting, 10% if I deduct the money, 70 lakh crore it has saved. What is the same proportion if I take it on the thermal side, other industries? You just calculate everything. You will understand the importance of this. That is why I often say that it is not that an efficient engineer is one who is very efficiently building something. A person who is able to see and then maintain its life. He is the real efficient. So, rehabilitation and retrofitting is something like that. And then I can keep giving several examples, starting from archaeological side and then from the thermal side or nuclear side, or several examples are there, why it is required, and then what are the techniques. Techniques, of course, there are experts to speak, and then starting from the earlier day, just with the line spotting of some introduction of some, say, bamboos. Several techniques are there. Stone stitching was there. I am surprised really. Several hundred years before, stone stitching was there. We were not even, we were all thinking that this, I was thinking rather that it is a latest or recent technology. So my dear friends, the message is very clear. And when it is unsafe, we are not forcing you to just live with that. But please respect the emotion which the people are carrying as far as the old building is concerned. Forget about the economic values. As soon as the old buildings are there, even in some movies you can see that before breaking the house that how much people will cry, but it is not that they are losing that money. It is the emotion they are attached with. It is the emotion we are attached with our ancestors. The values we are giving it to our ancestral work. The values we are giving it to our own culture. It is a cultural identity. So, maybe what is the technique all these experts are going to speak may not be completely applicable in the days to come. But certainly when you all rise up, you should come out with the technology to suit. If the building is safe to work, please continue and make this occasion much more useful than what you all thought. Because it is not just economy, it is much more than that. With this, I thank all of you for the patient listening and give me such a wonderful opportunity. Thank you very much.
See, it is only basic principles. There is no complicated, fourth degree equations, everything, nothing is there. It's only a weight. It goes down by gravity and you lift it, then shift it. That's all. And all those things, it's not a frame structure, load bearing structure. And what we did that time, it was only not load bearing, even mud was used inside. So how we have done it? So basic principles, equipments, and methodologies, application, finishing, conclusion. So this is the way I'm going to show you. See, the labor force, the labor cost, will come to it later. Okay. See, for a 1,000 square foot house, if you want to lift it for 3 feet, that will cost us around 4.5 lakhs, 4.5 to 5 lakhs. Well, then the repair and another thing. Creating a new floor and other things, that may work out cost another 5 lakhs or 6 lakhs. So overall it will be around 10 to 12 lakhs if you renovate old house into a, how it is done. See, what we do normally, below the plinth, we cut the wall into 1.5 feet, 40 centimeter, 40 centimeter like that. We leave a space of 45 and cut 45. Insert a jack. It's only a mechanical jack, not a hydraulic one. See, foreign countries, they do with hydraulic, but I'm against that. For a small house, you don't require that much of machinery and that much of costly equipment and all. If we make a mistake and if the machine fails, there will be some problem. Facing the problem is very difficult and that's why we leave it, and that is very expensive. The hydraulic system. Continuously, we will be introducing about 150 to 200 jacks all around 1,000 square foot house. Every 45 centimeters there will be a jack. We cut it and introduce. And here, this is the frame structure, this is the normal load bearing structure. See, below this, once we cut it, we lift it, and once you lift it, it will go from here, that will get detached. Three jacks or 4 jacks. You remove it and insert a channel and fix the jack below the channel. Continuously we do it, and once that is done, till we complete the jack, the channel will be there. After building, you can remove one by one. All the channels are welded. It is welded together as a single unit. See, the supports jacks is about, for every 1,000 square feet house, we will have to load up to 200, that weight of the house will be 200 tons to 250 tons. And that is every jack, around 150 to 200 jacks are used. Each jack will take a capacity is about 30 tons. Can take it. See, this is we introduce, after lifting, we introduce a brick made out of concrete. So the compressive strength we have given, the compressive strength of that brick will be 3 times more than the normal brick. So once the foundation is replaced by a concrete brick, it will be more stronger. The foundation will continue for another 80 years or 90 years. See, this is the brick, concrete brick we use. See, this is a jack. And we have another jack for rolling. See, the lifting is done by a jack of, it's a 1 gear, we lift it. After lifting, we wanted to shift it. We have rollers underneath the jack. That capacity is about 80 tons. This is one of the roller jacks. Say that the height will be about 12 inches, and once you shift it, it goes about 40, 50. Over that, we keep a wooden block in between to go for another 12 centimeters, 12 inches. See, look at the bottom of that. You see the gear, the shaft, roller or whatever you call it, iron roller. See, it is placed like that. These are the rollers underneath the jacks. Probably, I don't have to explain this thing to NLC engineers. You would have seen much bigger, this type of rollers in a roller lorry. See, this is the original mast, which was just projecting inside the highway. See, this was the one, 385 years old. The mast inside, it was laid with the asbestos sheet, roofing, we removed it. This inside, there is a Madras, this is a lime mortar building wall, and this has got arches, the windows has got arches. Over that, the asbestos sheet was laid. See, there was a meeting, first meeting, we had it at site. He is the architect. He is the architect Mushaki from Miyasi. This is the trustee of that whole thing. Mayan, we call him. Moin. So his nephew, no, he is the architect, sorry, he is the architect, and I am here. And this is the builder who did that, Karthikeyan, engineer Karthikeyan. So all of the team has done that work. See, this is the lifter. The person, jacking person is from Chennai, Babu. He has got a North Indian group of workers, so he controls them. So about 15 to 30 people will be there, maximum 30, around 20, from 20 to 30. The people will be there, and we are programming the schedule, how we are going to do. See, this is the plan. Originally, it was the Dargah was here. It was here in the same orientation. We lifted and shifted it 20 feet from here, this place. From here, see this, originally it was here and then shifted it. After shifting it, we have constructed a regular mast, Dargah, with the RCC pillars here, a hall. And behind that, there was another cemetery that was also repaired. And the design is contemporary design, mass design, but we followed the traditional system of domes and arches. See, this is the thing. It is, see, the client was very particular about the bottom soil below that cemetery. 14 feet. He said 14 feet, we have to pack it and take it. So we have done it like a cake packing, the whole thing. See how we have done it. We used girders, I sections cut like this, and then using the either mechanical thing we did with see, you'll be seeing it. So a pulley block with chain, and sometimes we used this JCB. Just pushing it inside. See, this is 14 feet below. You have done it continuously. 14 feet with 14, 14, 14. You have made it like a cake. But that time it was about to rain. So we have to protect that mud. We have done it like this. We have used the tarpaulin for that. And we had a pit also. We are very particular. The rainwater should not get filled. So we saw that thing. We made a ditch above that, the road level, and we made the water to flow that direction. So we saved that also. Few days we were in. This is home. See, this is the place. We have to bring that 14 feet straight. That is why we have dug up to this point. And from here we brought it. They did the only lime mortar work, it was there, and they had put marble over it, that was in cement. All the rest are soil, only soil. And the client was very particular about the soil. He said you should not lose the soil. The chunks, even a small chunk should be placed inside. That was very particular. The client was very particular about it. I sections continuously. Welded, we have welded it. Welded. No sheet. Just we have inserted. The I section was taking the soil. Yeah. See, look at this. After inserting, we have used planks, wooden planks with steel frames all around. We have made it. See, this is like something like, unconventional. You don't have theories for this. You cannot have any precedence for this, whether it can be done or not. It's purely, you have to design at site, as it is purely in your hand. As an engineer, what has to be done, we have to do it. See, look at that. We have packed it like that, here also, and the steel sheets are there. It is about 6 mm steel sheets. We have put it all around. See, then, after lifting, we want that to be pulled. So we created something like a path with this concrete blocks, where all 1, 2, 3, 4, 5 jacks were placed, moving jacks, that line. So we shifted along that. See, we have placed this is in this direction it is going to come. We have put a model here. How the pulling or pushing, everything is done by pulleys. See, this is the one. He is there. See, people are moving underneath because we are very clear that the whole thing was supported by I sections. And I was scared. Even the owner himself he went underneath. I told him not to do that. He said nothing. The whole thing is so. He is an electrical engineer. So he said I could see the supports very well. And nothing will happen. We went inside. We made that. See, we are pushing it with a jack. See this. Here one jack, there is a support, very strong support with concrete bricks. We were pushing that. See, lifting, we do one day, we will bring it up to 15 inches. One day. But after lifting, we remove the jacks, alternate jacks and construct a wall, support it. Then remove all the, we'll leave the jacks for further different level height. And it can take 1 week. Normally it took 1 week for every lift of 1 foot. So, what is that? This, one day we will shift jacking, the shifting, we made it 5 feet a day. We were pushed. See the change? I think you do a better job than this. I have a video, or to switch on that video. That is a video, underneath this. See, after that we are pulling it out, we are taking it outside with the pulley block. Purely manual. We have to do it with manual only. See the place you can't take a machine inside. You can't take a tractor or you can't take a dozer, JCB, nothing will be done. One thing you need a lot of patience and a lot of observation. You have to do a very careful observation. Your judgment is very important. How you judge and how you decide. What are the times you have to do it. We have very loose soil underneath. I made it very sure it was a made up soil. When we did that. If you do it, probably you engineers will think of something else different. But anyway, this was possible only in that place. Right? Huh? Chain pulley. Pulley block. That's chain pulley block. No, pulley block. Okay. That pulls it. See, this is how we use the wooden blocks. 4.5 inches by 4.5 inches, 12 mm by 12 mm. There's a blocks, there's holes up to this. Then we remove one after another and build a support like that and do it for a normal house. See the Dargah Magathiyanar, the Muslim, the Mughal year, 28/4/23, we shifted. That was the time we moved it. That time we had applied bitumen coat and over that they painted it. After filling it, anytime anybody opens it, they'll know this date and time. See, after that we shifted, we started constructing columns all around. RCC column, filling, everything was done. See, we maintain that same thing in their religion. They follow, they are very particular about the orientation. They don't want to change that, this what you call it, symmetry in a different, even 1 or 2 degrees also they don't permit. They want that same, they mark it, shift it to the same angle. We have done it. So, when our forefathers built, as chairman, ex-chairman said, not Grand, it was built with, it was an earthen dam. They call it seepage dam. You know how they did it? From 2000 years back. They put big boulders on a running water. They chose a place, they put boulders one after another. Due to gravity, it went inside and it got submerged in the sand. Whole thing was packed. Then the water always, during high flood level, the water seeps through. That is why it doesn't develop any pressure. That doesn't have any pressure in the dam because of that seepage. That is called seepage dam. Sir Arthur Cotton, a hydrologist who came for the British people to rule India, he was in Chennai. After seeing that, he said it was one of the greatest wonders of the world. First bridge, dam, still survives. He took the design, he copied it, and he has made a lot of dams in Europe after that. Seepage dams. Sir Arthur Cotton. That's why the hydrology, dams and everything, Percy Brown, I think, was a historian, there is a historian in history, architectural history. He says, Dravidians are the greatest dam builders after seeing Kalani. The column extended for a hall at the back. The original shifting was over, and to provide a dome over it, we have put a ring beam. You put a real same type of symmetrical dome. In that dome, how we did the reinforcement, you can see it. See, this is how we have drawn it to the ground, line by line. For every ring, we have done it, marked it and corrected it, and we have done a steel centering, plywood, flexible plywood. We did the curve, took a template and made a curve, and then in that we put the steel, and we got that there is a steel thing here. In a dome, when you do the concreting, when it is in the slope, the concreting, you need an outer concrete also, outer formwork also, but we have not done it. We have done layer by layer. So we took it to the top and then did it. I had worked in Kalpak atomic power project, where when we did the dooms, we had an inner formwork, outer formwork. The springing of that formwork on the dome starts with 90 centimeters. The bottom wall thickness will be 90, and at the top it will be 50. Shell. It is a shell structure. Similarly, we did not a shell structure. We didn't do any shell structure. We did the same thickness, both 6 inches, 9 to 6 inches. See, this is how it looks when you see it from down. And we have a lot of ventilation for that here, everywhere. And this is how it looks now. Lot of visitors are running. This is, we achieved the traditional, the heritage building. We have kept the heritage building in the same place. We have made it much better for the people to enter and go. So this is an additional thing. Why we do this? The first thing is sentimental reasons. everybody got a faith on this dargah. So everybody wanted that. And the client was ready to spend another thing. That is, see here the shifting is not that much. The construction is regular, very traditional construction. And the design was done by his nephew, architect Mushakit from Miyazi School of Architecture. He did the whole design for the concept. Even the color, everything is given by him. And at the back there was a mother, they call it Mother Samadhi. That is the thing. This is one after finishing. See, it is opposite to Maharaja's shop. It is there. See, this Tanjore, it is in the history. In Tanjore, it is about 385 years old. This structure is in the history. So that is one thing. They wanted to renovate, you can't say renovate, replace it, or even you can't say replace. Retrofitting also, it's not an exact word for that. It is strengthening and relocating. That's why I said jacking, shifting, and then lifting, jacking, lifting, and shifting. This, we have followed all the traditional motifs and the construction techniques, we did that. The same thing, this is a brass. Here, one problem is lighting arrestor. We have taken the lighting arrestor nearer to that, higher than this level. This, what you call it, pinnacle, above that. So we were able to tackle that also in this. See, the old and the new. Same location, same angle, parallel to the road. We maintained everything and exactly we were able to replicate the angles and other things. It was one of my career landmarks in that. Giving back what I learned, giving back what I had. So this is one of the very important thing in my career. By doing this, it is we have renovated or regenerated that thing, concept of that mask and other. See, another, I come from a place where Tanjore, what is famous for? Very big temple. Perudaya, Tanjai Perudaya. You know what is the speciality of the temple? Sahar wanted me to add something to that, so I am just getting into that. As an engineer, what do you know about it? Yes, sir. Foundation, one thing. Another. What is said, commonly said? Shadow. Shadow falls. I have shown the shadow also. That is not exact thing. The shadow Buddha then how not? Uchi Veyilil Niralsaya Gogram. That's on the noon sunlight. The shadow doesn't fall. But that means it is a truncated pyramid. It is 4 sides at the bottom. The top also 4 sides. The bottom is about 100 feet by 100 feet. The top is 27 by 27. And it is in the height of about 200 feet. And above that, the crown is there. What you call it, grivam, the neck portion is there. That is about 30 feet. Over that, the Kalasam is there. The Kalasam shadow doesn't fall outside at noon throughout 365 days. Normally, everywhere, even Neyveli, you have 2 shadowless days at noon. 2 days. One is from the sun travels from south to north. That is Uttarayanam, they call it, from north to south, Darshayanam. The 2 days, the sun comes right above your latitude and longitude, exactly about Neyveli. That day, it won't fall. Similarly, every town has got that, but in this big temple, all the 365 days, the shadow doesn't fall outside the base. Noon, you will see the shadow. Morning, you will see the shadow. I have shown the shadow that day. So, this is that a place where the history stands. 1,000 years of history, we are breathing. Tanjorians, all the Tamilians should be very proud of this, especially people who are in Tamil Nadu. Should be proud of this architectural wonder. It is an architectural wonder and engineering marvel and spiritual glory. This has got such a beautiful thing. See, the whole place when you walk in, it engulfs you, it takes you. You forget about who you are. If you just go there, it will take the trance, you get into that trance level. It's so beautiful. Very, I've been going for the past about nearly, I've crossed 75, but still, nearly about 65 years, 70 years I've been going. Every day I go there, I see a new thing, it's regenerating. And that's the beauty of that. A place was built, there is no mortar. All of you know that? There is no mortar in between. It's stacked. The stones are stacked one over the other. And it is a hollow structure till the top, up to 200 feet. You know the depth of the foundation? Depth of the foundation, 1.5 meters, that is 5 feet. It was done with the technique of something what we call it modern engineering raft. No steel, no mortar is used, but its stones are packed straight and then sand is filled around the sides and they poured water, saturated that with water. So consolidation has taken place. The depth of foundation, the stones were about 4 feet and they put another 4, above that. From there, that is the base. They have done it, 5 feet. So it's a marvel. 1,000 years back they have done it without foundation. Well, that time, was there any engineering college? Any professors to nobody? How they know? How they know this? And they say it is only by divine guidance. The Sthapati, the chief Sthapati is Rajaraja Kunjaramalla Perandacha, chief. The next one is second one is Nitya Vinoda Perandacha. The third one is Kandaraditya Perandacha. So 3 architects, they were called architects by the modern nursing, but they are the people who did this, designed this. So those 3 people, and especially the top chief architect, Rajaraja Kunjaramalla Perandacha, Rajarajan has given credit for all these people in the inscriptions. He has given the names and written the names there. So that is giving the credit to the person who has done it. They have done it. We have shown the world that 1,000 years back, the due credit has been given to the person who has done it. So that itself, our engineering fraternity should be very happy. We have a wonderful engineering marvel as well as wonder. It is a wonder. You don't have any answer for that. It is in our district, Tanjore. So, you are also Tamil Nadu. Say Tamil Nadu. Tamil Nadu is one thing you can take it. So that is the speciality of the temple. And I think he wants to say something more, but anyway, when time comes. See, this is the person, the owner of that, Moin Shakaf, and he is Muzagir, architect Muzagir, this is myself, and the centering fellow, Shakti, a very good person. He has done a wonderful job. Whatever we wanted, he reproduced. The centering person, Shakti, and then my assistant, office assistant. This guy is my office assistant. So only the core, we forgot, we missed the builder, we missed the person who lifted it. So we were the thing behind that. And I did a sketch of it and then sent it to, I do a lot of urban sketching. So one of my sketches where I did for Ramzan, greetings I sent to those trustees. But anyway, this is what I have done, and if you want to ask any question, you can ask me. Do you have any questions?
Below the
soil.
But I saw you insert in the horizontal position.
Yeah, the one has a bottom plate. I have used it as a bottom plate.
Instead of minor axis, had you inserted in my major axis, vertical direction, it would have still given better results.
No, we have placed it so close and we have put underneath another support. So I will say, I wanted thing to go easily inside. If you go like this, we may require a lot of eye sections. The thing, eye sections was very minimum eye sections I have used. I have used about 8 or something horizontal.
In that case, for the horizontal I section, that rough portion will be getting
The
the soil from.
the soil was loose at the top. As we when it moved, nothing, no. As and when we moved it, we could see the soil coming down.
Major action should
Yeah, as you say technically, the I section, it should be placed like this. But in between, the gaps were wide and we expected some failures in between. So we never wanted that. Below that, we introduced another I section, 1/3 distance, from front and back.
Just for easy insertion, you
Yes, yes.
Okay.
And we made it very sharp. Now we have cut it with the gas cutting. Then we used that. This pokeline or everything. We pushed it 10 feet. 20 feet.
20 feet.
20 feet. We moved from that 20 feet and moved towards west 3 feet.
Okay. Pradi, what was the progress, sir? Progress of shifting? 5 feet. 5 feet.
5 feet per day.
Okay.
But in vertical, every foot it takes 1 week to pack. We remove alternate jack, construct the joints, then we lift it, then do that. So that shifting, height shifting, it will take nearly 1 week. The whole 1,000 square foot house. Rolling jacks here. Now rolling jacks we had used about 20 or 22.
Is there any spacing you have given for rolling?
Yeah, it is adjacent about 2.5 feet. We have put a concrete, something like a block now, over that.
Like you mentioned, around 130 jacks you have utilized. Sir, while you are lifting, you said alternate jacks you are using. The pace of lifting is how much? Is it a standard thumb rule is there, or it's like...
No, placing of jacks is, you have a, say it's a totally practically absorbed the thing. Say 1 foot, 45, 1.5 feet. That is the center line you mark. You cut the foundation below the plinth level or whatever you call it. Then place the jack here, lift it. That will go above this.
Okay.
So once you lift it about 15 centimeter, 1.5 feet, 15 centimeter inches, you remove this.
Okay,
and
sir.
place another.
Sir, how do you lift? Like,
It's a manual thing.
So, all 100 you engage at a time, or 50
No,
or
each person will push 10 to 15 jacks.
Oh, okay.
And they will give a signal. It's when you do quarter, it clips by 1.5 mm or something, very minimum.
Okay. Because, sir, like in recent times, I have seen many videos in YouTube and all where this lifting of plinths is going on in various parts of the country. Sir, is there any, standard methodology?
No standard. I have spoken to ISI people.
Okay.
The reason I had been to Chennai, Coimbatore ISI as a chief guest for a 75th year celebration.
Okay.
I asked them to have a code for this.
Mm-hmm.
They said they don't have any input.
Okay.
No? Practical application. There is a gap between theory and practical. There is no theory. So this is so I do this way. As you say, some people may go for a special device where putting inside, no, with a wider.
Okay. Thank you, sir.
But you are dragging it out. How do you stabilize the soil beneath that?
Soil. It slides through the soil. Inside it comes up. I have made it. Did you notice that sharp edge? That pierces. The half goes up and the balance at the bottom it remains. That is pulled with a chain pulley block.
Do you run any stabilization?
Any
Stabilization of the soil beneath it?
you don't have to stabilize. Why do you want to stabilize?
Because while you are...
So sometimes if the soil falls, see here the main thing is soil because it is attached with the body. They believe that body is still there underneath. So the remains are still there, so they don't want anything to fall down. Any soil. They are very particular, the soil should be carried. The depth of soil. It is loose because they have put the soil inside. The body is kept at a height of the road level. That time existing road level was about 6 feet lower than what it is now. And below that 6 feet, they dug a pit. That pit they placed. So it was around 12 feet. But we took another 2 feet as an extra. 14 feet we did it. After seeing the soil, I could make it. It is loose. It is not that tight. Suppose if we had crossed any boulders inside, once we knocks, we'll know. Then we try to do an order. Remove that boulder first.
remove பண்ணிட்டீங்கன்னா அதுல ஒரு ஹாலோ ஸ்பேஸ் இருக்கும்.
எதுல ஹாலோ ஸ்பேஸ்?
கீழ ஐ செக்ஷன் இன்சர்ட் பண்றீங்க சார்.
ஆமா.
இன்சர்ட் பண்ணிட்டு once நீங்க ஷிஃப்ட் பண்ணதுக்கு அப்புறம் ரிமூவ் பண்ணிட்டீங்க.
ஆமா.
பண்ணதுக்கு அப்புறம் அந்த ஐ செக்ஷன்ல ஒரு ஹாலோ ஸ்பேஸ் உருவாகும்ல.
ஹாலோ ஸ்பேஸே இருக்காது. அந்த இடத்துல அந்த சீட்டிங் வந்துரும் அப்படியே.
மேல வந்து அந்த மேல இருக்க லூஸ் ஆகி தான் கீழ வந்து காம்பாக்ட் ஆகுது.
அந்த காம்பாக்ட்டை நாங்க டைல்ல பேக் பண்ணிருப்போம்ல. இந்த ஸ்டீல்ல பேக் பண்ணிருப்போம்ல. ஒவ்வொரு செக்ஷனா எடுக்கிறப்பயே it is we go in a higher level, slightly higher level போயிடும். Not on the lower level. அங்க இருந்து இது வந்து கிட்டத்தட்ட ஒரு அடி 1.5 அடி ஸ்லோப். அதை எடுக்கிறப்ப அந்த சாயிலை இது பிளாக் பண்ணிடும்.
அந்த மூவிங் போற வரைக்கும் அந்த ஐ செக்ஷன் ஃபுல்லா அந்த எண்ட் ஸ்டேஜ் போற வரைக்கும் ஐ செக்ஷன் உள்ளே தான் சார். உள்ளே இருக்கும். once நீங்க அந்த ரிமூவ் பண்றப்ப என்ன ஆகும் அந்த ஐ செக்ஷன்? ரிமூவ் பண்ற நேரத்துல அந்த பின்னால விழுதுன்னு சொல்றோம், கீழ ஃபில் அப் பண்ணிக்கும் சாயில். once you remove பின்னால பேக் பண்ணிடும். அதுல இன்னொரு எங்களுக்கு ப்ராப்ளம் வந்துச்சு. அப்படியே சாயில் வந்து கிராக் ஆகி வாட்டர் கண்டென்ட் ரெடியூஸ் ஆனோம்னா ட்ரை ஆகி கிராக் ஆச்சு. உடனே லைமும் வாட்டரையும் இது பண்ணி ஸ்ப்ரிங்கிள் பண்ணிட்டோம். சுற்றி சைடில் ஸ்டாக் பண்ணிட்டோம். லைம் அண்ட் வாட்டர். தேங்க்ஸ்.
தேங்க்யூ. நீங்கள் சொல்லுங்க ப்ரோ சார்.
I came to know there is a building which is shifted in Chandigarh. And this is the first building shifted in India. I think so. Is it correct, sir?
I don't think so. ரொம்ப நாள் நிறைய பண்ணியிருக்காங்க அதுக்கு முன்னால எல்லாம். மேபி சண்டிகரோட சைஸ் எவ்வளோன்னு தெரியல. they'll say இவ்வளோ ஸ்கொயர் ஃபுட் பிக்கெஸ்ட் ஏரியா ஒரு ஃபர்ஸ்ட் மார்க்கும்னு சொல்லியிருப்பாங்க. பட் நிறைய இதெல்லாம் அதுக்கு முன்னால nearly I can say about 15 years they have been shifting doing this technique. Last 15 years.
How this capacity of the jack?
Jack with 35 tons.
35.
Sir, so 1 minute.
You should answer. One more thing, how to ensure the stability of the building after shifting, sir?
After shifting, we don't have any cracks. We don't have any settlement. That's enough. And whatever we have given underneath is more than the 3 times more than the load bearing capacity of a brick, ordinary brick.
You are matching with the newly constructed foundation.
That's it. Only soil is there, and we have enclosed it with an RCC wall. We have consolidated and compacted that with the adjacent wall, RCC wall. In a confined area, you can fill it with sand and you can take more load. It's a confined area. We cannot do it further in foreign body. Secondly, cement or lime, or that will see when you add cement, the water content in the cement is taken by the dry soil. When the setting is, it doesn't have a proper setting, cement, all custom, water will come. அதனால அந்த இதுக்கெல்லாம் காம்ப்ளிகேஷனாக போக வேண்டாம். சிம்பிள் மெத்தட்ஸில் போங்க, அவ்வளோதான். காம்பாக்டட், fill it with sand, close it.
Tirunur statue erected in Kanyakumari. You have any idea about what is the type of foundation?
Foundation, they have put it on a rock. Rock மேல ராக்கை பிளேஸ் பண்ணியிருக்காங்க. அந்த ராக்கை பிளேஸ் பண்ணுறப்போ அதில் டபுள் ராட்ஸ் வச்சுருப்பாங்க. டபுள் ராட்ஸ் இன் த சென்ஸ் it will be a hole, மேலேயும் இருக்க ஸ்டாச்சுலேயும் இருக்கும். அதை கனெக்ட் பண்ணிடுவாங்க. அதில் வந்து என்ன பண்ணுவாங்க, நார்மலாக they don't use ஸ்டீல்லாம் பண்ணியிருக்க மாட்டாங்க. They have used lead or high quality of stainless steel. ஏன்னா இப்போ அவங்க கணவேஸ்தபதி இருந்தப்போ அதை பண்ணியிருக்க மாட்டாங்க. ஸ்டோனே வைப்பாங்க. The base is so much it won't get toppled. அதை வந்து அந்த அங்கே இருக்க ராக்லேயே ஒரு 3 feet 4 feet டிக் பண்ணி அதுலேருந்து ஆரம்பிச்சிருப்பாங்க. And it is placed as a single rock. அதை வந்து வச்சு பார்த்துருப்பாங்க. லேயர் இன்னொன்று தெரியுமா, அந்த திருவள்ளுவர் வந்து லேயராக இருக்கும். நடுவில் ஹோல் இருக்கும், that is filled with concrete. அதனால தான் you see the leaching of cement, இது ஒரு ஒயிட் பாடியில் வருது. It is in layers. ஒரு ஹியூஜ் ஸ்டாச்சு பண்ணுறப்போ, டு ஸ்கேல் பண்ணுறப்போ, சின்ன ஸ்கேலில் அந்த இதை மார்க் பண்ணிடுவாங்க. அந்த ஹைட்டு இதெல்லாம் ப்ரொபோர்ஷனேட்டாக அப்படியே 100 டைம்ஸ் ப்ரொபோர்ஷனேட்டாக இது பண்ணுவாங்க, 50 டைம்ஸ் கொண்டு போவாங்க. அப்படி தான் மாடல்ஸ் பண்ணுறது.
Thank you, sir. Sir has so much to talk to you or tell you all NLC executives because you are going to stay back. The students will be going to the precast yard for a site visit, and even if you want, you can also go. But all the people you can 15-20 minutes after the session you can interact with our.
Whatever you have doubts, students.
Now I request our Karthikeyan, Executive Director and the Township Administrator, and brain behind this seminar, and request him to come and hand over a small memento to our Rajendra. I now request our Shakti Murugan to present his speech, please.
We will see if every one of you is having a good internet connection. I think the farms should open up. Archaeology Department with Tamil Nadu government. Apart from these, INTAC, Indian National Trust for Architecture and Cultural Heritage. This is a NGO started during the Rajiv Gandhi times, and that is some NGO that is still practicing conserving heritage, protecting heritage, preserving and renovating heritage. Apart from these, there are very few players in the market, in the field, who are involved with heritage and heritage-related matters. Thankfully, in the current scenario, from 2017 onwards, Tamil Nadu government has incorporated heritage schedule of rates for lime concreting, lime masonry, Madras terrace, and these types of specialized items, otherwise which wouldn't be there in a regular schedule of rates. So from 2017 onwards, they have introduced this. And a couple of days back, there was a 700 crore sanction, rupees sanction on reforming, renovating temples across Tamil Nadu. So that is a very welcome thing from the Tamil Nadu government in the past 3 or 4 days. That's a very latest news. Being an architect, I understand the relevance of what an engineer could do, what a civil engineer could do. From the very beginnings, like Sir was talking about 1771, when the engineering institution was started in somewhere in the France area. Even before that, there were artists who were writing artistic notions, artistic aspects, along with engineering drawings. That was 11 BC. Engineering drawings, it is not something that is recent. It has been there. It's basically form and structure, both combined together. They are inseparable. Form is something that we deal with, architects. Structure is something that you guys deal with. Without these two, there is no architecture. This people very well understood in the ancient times. Only now, there is a very big divide between an architect and a civil engineer. And I am seeing only 2 more architects here in this entire forum. And the rest, everybody is probably a civil engineer or some other engineering field. So the point is, we are segregating ourselves into super speciality domains. In the name of super speciality, in the name of refinement, we are trying to refine ourselves into small groups. But in doing so, we lose the grounding. We lose the roots that it all became, or it all got its form from the basic root structure, where it is the core, form building. So we will talk about this form building in the course of this presentation. I am going to take you through what heritage is for general understanding. So we have students here. Can any one of you please stand and tell what heritage is? We've been talking about heritage. We've been talking about culture. Can someone say? Palamayana, okay, Palamayana, old. Parambaryam, okay? Any other interpretations? Please feel free. Culture? Culture representation. Okay, culture representation.
It's what we inherited from our forefathers.
இப்போ இந்த மாதிரி மாலை போடுறது heritage. So that is also heritage. And there is a very big epistematic data embedded here. The Nasi that you see in a Dravidian temple, Nasi na in the Mari shape la onnu. That's called a Nasi Kudu. When it comes on the corner of the temple, it's called Nasi Kudu. When it has 4 sides, but when it is like a vaulted structure like this, it is a Nasi. That Nasi is a representation of a cave from the primordial times, even before the Jain times, when people were living in the caves. So there was always a symbolism attached to it, that when you see a curvature like this or something like this, the central part or the core part houses something important. That's the message. The garland also does the same. The nulaivail does the same. The cave does the same. They all give you the same symbolic idea. This Nasi Kudu is in repetition in a temple when you see it. The same Nasi Kudu, when it is moved in one axis, becomes a salai. So we will come to that later on. So there is so much of knowledge system that we are carrying right now from our past. The chair that I sat right now is a improvised or more industrialized version of a Italian designer's chair, which was called a cantilever chair. The tables that we use, the mic that we use, this pedestal that we use, this form of this pedestal has got its form from the Roman columns. So whatever that we do, we have some inferences taken from our past. It's the knowledge that we take, it's the inspiration that we seek from the past to live today and to plan for tomorrow. The phones you have, the scale, the proportions, 1:1.618, the golden ratio. The business cards you hold, 1:1.618, again the golden ratio. Golden ratio comes from the Fibonacci series. So Fibonacci series na kandupidichadu eppo? During the Renaissance times, during the 13th century AD. And before that, we had temples from almost 4th or 5th century. The temple near Mahabalipuram, Saluvan Kuppam, that is supposedly the oldest temple structure available in Tamil Nadu. That's a Murugan temple for Muruga. That is somewhere in the coastal belt near Mahabalipuram, Saluvan Kuppam. There is one more point that I want to make it clear. We are in the era of data overdose, data confusions, and this data era, this AI era is a boon and also a curse. Boon na oru varam, curse adu oru savam, rendume. Yarala data la updated ah irukromo, இன்னைக்கு நேத்து நடக்கிற விஷயங்கள் வரைக்கும் நம்ம அப்டேட்டடா இருக்கலாம். அது படிப்புல ரொம்ப அவசியம். That is, to understand data and to be updated with data is going to be very, very helpful when it comes to academics, when it comes to research. Most of the scientists here, most of the engineers here who are working with a nationalized institute like this, Neyveli Lignite Corporation, I think there is a vast scope of research that has been done here. There have been a lot of predecessors who has laid different paths for you to work on new avenues in your own field. That way, research holds a very, very important crux at this juncture. அதுக்கு தேவை data. And the data எங்க இருக்கு? Right now it is there in the internet, it is in the cloud. Just matter of a question. Right question, you get the right answer. You don't have to go anywhere. Sitting here, I can do almost 85% of my work that I have to find. This is when the data is assimilated, recorded, and then uploaded into the cloud or into the database. What happens before? The reason India is lagging behind in research, the reason India is lagging behind in path-breaking original works is because we don't have proper documentation of our path, our journey. We have been entrained with oral traditions. We have very strong oral traditions, or we had oral traditions. And we had written aspects which got destroyed during so many different times. The temple is one such embodiment of knowledge. So if someone is able to read the temple in its holistic nature, then there are so many information databases available that we can decode. How many of us know? We don't know. We've lost that knowledge system. How? Because of the colonial times, our knowledge system was perfectly cut, systematically cut. They made sure that we cut ourselves from our cultural roots. Only then we become floating people without any rooting, without any grounding, without any identity, without any cultural identity. So once we become that Nadodi, it is easier to handle because you will be dependent on food, dependent on place, dependent on resources. So the external forces, when they come in, it becomes easier to hold you, to control you, and to take things from you. So, இது ஒரு சைடு. இதுக்கு முன்னாடி டெம்பிள்ஸ்ல, இன்ஸ்கிரிப்ஷன்ஸ்ல, ஓரல் ட்ரெடிஷன்ஸ்ல, குருகுலம்ல எல்லாத்துலேயும் we've always had people talk stories, people talk information in the form of stories. So we got conveyed a lot of database aspects, information through oral traditions. Greek and Roman mythology was written in clay tablets. Still it is surviving. Without any dilution, without any alteration, whoever has written, அதை எந்த மறுவல் இல்லாமல், எந்த பயாஸ் இல்லாமல், இன்னைக்கு எந்த கான்டெக்ஸ்டில் அதை எழுதுனாங்களோ அதே கான்டெக்ஸ்டில் இன்னைக்கு படிக்க முடியுது. நம்ம ஹிஸ்ட்ரி அப்படி இருக்கா? மாற்றி மாற்றி எழுதி, ஒவ்வொரு பொலிட்டிக்கல் ஐடியாவில் எழுதி, ஒவ்வொரு பொலிட்டிக்கல் வில் பேஸ் பண்ணி எழுதி, இன்னைக்கு நம்ம பார்க்குற கையில் கிடைக்கிற எல்லா இன்ஃபர்மேஷனும் யாரோடையோ மைண்ட் செட் அதில் ஒரு பங்கு வகிக்குது. அப்போ ஆக்சுவல் ரெக்கார்டிங் ஆஃப் இன்ஃபர்மேஷன், டாக்குமெண்டேஷன் ஆஃப் டேட்டா அப்படின்னா என்ன? அதுதான் நாங்கள் எங்கள் உயிரை கொடுத்து செஞ்சுக்கிட்டு இருக்கிற வேலை. இந்த லாஸ்ட் ஃபியூ இயர்ஸாக பண்ணிகிட்டு இருக்கிறோம். அதை பற்றி நாம் உங்களுக்கு காமிக்க போகிறோம். நெக்ஸ்ட். ஸோ our practice is built on the conviction that heritage conservation is one of architecture's most vital civil engineering responsibilities. என்னுடைய ஃபாதர் வந்து சிவில் இன்ஜினியர். அவர்கிட்ட நான் நிறையா கற்றுருக்கிறேன். சிவில் இன்ஜினியருங்கிறதுனால, ஆர்கிடெக்டுங்கிறதுனால எங்களுக்குள்ள வாக்குவாதம் வரும். நான் சொல்கிற சில விஷயங்கள் அவர் அண்டர்ஸ்டாண்ட் பண்ணிக்கிட்டு அதுக்கு ஒரு விதமான பதில் சொல்லுவார். அவர் சொல்கிற விதங்களை நான் ஒரு விதமாக அண்டர்ஸ்டாண்ட் பண்ணிக்கிட்டு அதை நான் அசிமுலேட் பண்ணிக்குவேன். ஸோ ஒரு விதமான நாலேஜ் டிரான்ஸ்ஃபர்மேஷன் அவ்வளோ நல்லா நடக்கும். எங்களுக்கு புரியும், ஒரு ஆர்கிடெக்டும் ஒரு இன்ஜினியரும் சேர்ந்து கான்செப்சுவலைஸ் பண்ணால் ஒரு பில்டிங் எவ்வளோ அழகாக வர முடியும்னு. பட் ப்ராக்டிக்கலாக நிறைய பேர் அதை பண்ணுறதில்ல. ஆர்கிடெக்ட்ஸ்னால் 2 கொம்பு அப்படின்னு நினச்சிக்கிறாங்க, கிடையாது. இன்ஜினியர்ஸ்னால் டெக்னிக்கல், ஆர்கிடெக்ட்ஸ் காற்றுல கதை எழுதுவாங்க அப்படின்னு நினச்சிப்பாங்க, அதுவும் கிடையாது. 2 பேர்த்தோடைய நெசசிட்டியும் பர்ஃபெக்டாக அலைன் ஆகி அதுதான் இந்த ஃபார்ம் பில்டிங். ஃபார்ம்னா ஷேப், அந்த ஒரு ஆஸ்பெக்ட். இது திருப்புலமங்கை அப்படின்னு சொல்லிட்டு கும்பகோணம் பக்கத்தில் இருக்கிற ஒரு கோயில். இது எங்களுடைய ஒர்க். லெஃப்டில் இருக்கிற இமேஜ் அது என்னன்னு யாராவது சொல்ல முடியுமா? அது என்ன டைப் ஆஃப் இமேஜ்? எனி ஐடியா? அது கீழே எழுதியிருக்கு, பட் அது அதில் நான் எக்ஸாக்டாக நான் கேட்குறது அதில் இல்லை. இது டிராவிடியன் ஸ்டைல் ஆர்கிடெக்சர். ஆனால் நான் இந்த இன்ஃபர்மேஷன் டைப் கேட்குறேன். இது ஒரு இமேஜ். இந்த இமேஜ் அதில் நீங்கள் பார்க்குற இந்த கோயிலை நீங்கள் ஃபோட்டோவாக எடுத்தால் இப்படி இருக்குமா? கரெக்ட். ஃபோட்டோகிராமெட்ரி. திஸ் இஸ் சம்திங் கால்ட் ஃபோட்டோகிராமெட்ரி. அதுவும் கேமராவை யூஸ் பண்ணியே ஃபோட்டோஸ் எடுக்கிறது. ஆனால் யூ டேக் 700-800 images using drone as well as handheld camera, and you combine all these images in a software, and that software, by triangulation, it computes points in the 3D, and that points are called point cloud data, and these points, when connected with planes in triangular form, they become meshes, and these meshes are overlaid with color information, they become textured surfaces. This is the most recent way or system in documentation, in architectural documentation. இது எங்கேருந்து இந்த ஃபோட்டோகிராமெட்ரி ஆர்கிடெக்சருக்குள்ள ஹெரிட்டேஜ்குள்ள ஊடுருவுனுச்சு அப்படின்னா, it came from the remote sensing. The satellite data they had few softwares to calculate the angle from which they take, focal length of the lens, the resolution, and the movement, the overlaps. All these were computed, and you had a actual near to scale, actual to the ground reality, a particular image which you can scale. So this is a ortho-corrected scaled image which contains almost 400 plus photographs combined together. This is a screenshot of a 3D like a scanner. You imagine, and I think most of you understand what an elevation is. When you draw an elevation of a structure, what will you see? You will just see the profile of this, right? So you won't see the sides of it. This is exactly what is being done there in that temple. So that temple is equivalent. That temple's image is exactly equivalent to a drawing, like a mission drawing, like an architectural drawing. So where the drawings become useless, the photogrammetry images become relevant, because small curves, small intricate details, கையில் வரைகிற, கையில் செதுக்கிற அந்த ஹியூமனைஸ்டு ஃபார்ம் நம்ம சொல்கிறோம். மிஷின் பர்ஃபெக்ஷன் அண்ட் ஹியூமன் எஸ்தட்டிக்ஸ் அப்படின்னு சொல்கிறோம். இது கைத்தறி புடவை அப்படின்னு சொல்கிறோம். இது மிஷினில் பண்ண சிஎன்சி கட்டிங் அப்படின்னு சொல்கிறோம். சிஎன்சி கட்டிங்க்கும் கையில் செதுக்கிறதுக்கும் உள்ள டிஃப்ரென்ஸ் என்ன? கையில் செதுக்கிறதுல ஒரு விதமான உயிர்ப்பு இருக்கும். இட் இஸ் மோர் ஹியூமனைஸ்ட். It has a lot of human craft value. It is a work of human skill set. ஆனால் மெஷின் அப்படி கிடையாது. ஸோ எதுவுமே கைப்பொருளாக அதை செய்யும்போது அதுக்கு வேல்யூ வேறு லெவலில் இருக்குது. அப்போது செதுக்கும்போது, கார்வ் பண்ணும்போது ஒவ்வொரு ஸ்தபதிக்கும் ஒவ்வொரு தச்சனுக்கும் ப்ரெஷரில் அவங்க சில கேரக்டர்ஸை கொண்டு வருவாங்க. ஒளியை அழுத்தமாக அடிக்கும்போது டீப்பர் வெட்ஜ் ஃபார்ம் ஆகும், லைட்டாக அடிக்கும்போது தின்னர் லைன் ஃபார்ம் ஆகும். அதில் எந்த ஆசான் என்ன மாதிரியான வரைகிற மெத்தடை வச்சிருக்கிறாரோ அவங்க சிஷ்ய பிள்ளைங்க when these disciples, when they carve their school of style, when you say இவங்க ஸ்கூல் ஆஃப் தாட் அவங்க ஸ்கூல் ஆஃப் தாட் அப்படின்லாம் சொல்லுவோம். அந்த மாதிரி ஒவ்வொரு ஆசானுடைய ஸ்கூல் ஆஃப் தாட் அதில் இம்ப்ரிண்டடாக இருக்குது. ஒரு டிராயிங்னால அதை ரெக்கார்ட் பண்ண முடியாது, அந்த இன்ட்ரிகசிஸை ரெக்கார்ட் பண்ண முடியாது. அந்த இடத்துல we have this photogrammetry as a savior. The same point cloud information can also be acquired using LiDAR, laser. So, இங்கே இருக்கிறவங்க நிறைய பேருக்கு LiDAR தெரிஞ்சிருக்கும். ஏன்னா உங்களுடைய ரிசோர்ஸஸ் உடைய என்டையர் மேப்பிங் இஸ் அ காம்பினேஷன் ஆஃப் ஜியோ இன்ஃபர்மேஷன் சிஸ்டம், அதில் இருக்கிற மேனேஜ்மெண்ட், அதுக்கு வர டேட்டா, சேட்டலைட் டேட்டா, டெரஸ்ட்ரியல் ஃபோட்டோகிராஃப்ஸ், நீங்கள் தரையில் செய்யக்கூடிய ஃபீல்ட் இன்வெஸ்டிகேஷன்ஸ், வாட் எவர் எக்யூப்மெண்ட்ஸ் தட் யூ யூஸ் டு சர்வே அண்ட் ஸ்டடி தி என்டையர் சர்ஃபேஸ் அண்ட் தி bottom layers, all these things are put on a GIS database and probably you are using it. If not GIS, there is something else called BIM, Building Information Management System, where the entire structures, HVAC na purida, heating, ventilation, air conditioning, MEP, mechanical, electrical, plumbing, architectural drawing, shop drawings, vendor drawings, working drawings, plumbing and sanitation drawings, services, water supply, fire service, navigation based aspects, managerial layer, all these are embedded onto a single file, master file. அதுதான் இந்த BIM. On the master file you will have a complete 3D reconstruction in a digital format. On the 3D reconstruction you get data from LiDAR. All the airports, all the major tunnels, all the major complex architectural and engineering projects, they are all utilizing LiDAR surveyed data into Rhino, into Revit, into BIM, and only then they are able to do whatever they are trying these days. So our scenario of work, our scenario of study has completely transformed. இன்னைக்கு சார் சிவஞானம் சார் சொன்னார், சண்முக சுந்தரம்ங்கிறவர், he was instrumental in writing up specification for steel prefabricated structures. நான் படிக்கும்போது 2003-2002 ஆல்டர்னேட்டிவ் மெட்டீரியல்ஸாக ப்ரீஃபேப்ரிகேட்டட் ஸ்ட்ரக்சர்ஸாக ஆர்கிடெக்சரில் தியாகராஜர் காலத்தில் படித்தேன். இன்னைக்கு அது அப்சலீட். இன்னைக்கு மெட்டீரியல்ஸ் வேறு விதமாக வந்துடுச்சு. இன்னைக்கு அப்சலீட்டுங்கிறத விட தேவைப்பட்டால் அதை யூஸ் பண்ணலாம். இஃப் சம்ஒன் நீட்ஸ் இட் தே கேன் யூஸ் ப்ரீஃபேப்ரிகேட்டட் materials, thin ferrocement materials, if they want to. But the actual material science today is evolved far more. Before coming here, I did a very small research. I wanted to know what is the most latest update in civil engineering. And civil engineering, to my surprise, they have started working with quantum physicists. I don't know what they are working on. Civil engineers have started working with quantum physicists, quantum mechanics. Do you think there is a possibility of knowing what they are doing? So, endless options. And there is a concrete which can heal. Micro pores, microstructures inside the concrete is self-healed utilizing bacteria that bacteria eats up certain things and excretes calcium, which gets and clogs all the pores. Thereby, micro fissures inside a concrete are completely sealed. This is a very recent phenomenon in civil engineering. Civil engineers have started working on physics, chemistry, biology. So, it is not a single field. When you travel into academics, you will realize at a certain point that all these things converge. All roads lead to Rome சொல்லுவாங்களோ, நீங்க எவ்வளவுதான் தனித்தனியா branch off பண்ணி படிச்சாலும் அதோட தாற்பயம் எல்லாம் ஒண்ணா தான் இருக்கும். The philosophy remains the same. So it's good to understand our studies, our research in a very, very broad, uninhibited, uninhibited. உங்களுக்கு இன்ஹிபிஷனே இல்லாமல் எனக்கு தெரியும் தெரியாது அப்படிங்கிற மாதிரிலாம் யோசிக்காமல் அதை வந்து ரொம்ப பிளெயினாக நியூட்ரலாக கற்றுக்கிட்டோம் அப்படின்னா ஐ திங்க் தேர் ஆர் ஸோ மெனி கிராஸ் ஏஜென்சி கிராஸ் அகடமிக் லிங்கேஜஸ் தட் யூ வுட் பி ஏபிள் டு கம் அப் வித். ஸோ இந்த லைடார் இமேஜ் ஆர்த்தோ கரெக்டட் இமேஜ், இது லைடார் கிடையாது, இது ஃபோட்டோகிராமெட்ரி. திஸ் இஸ் taken using a drone with combination of a handheld camera. On the right, we did a rasterization of this particular image and we have marked the conditions. So that's called a condition assessment. As a conservation architect, when we study a building, we study and understand the conditions and we map it on a scaled drawing. So that's the condition assessment drawing. Next. So, what is heritage? I think we started asking, somebody responded. So, எனக்கு தெரிஞ்சு எனக்கு வார்த்தையார் ஒருத்தர் சொன்னது நான் சொல்கிறேன். ஒரு தேவை, அந்த தேவையை டெய்லி பேசிஸில் செய்யும்போது அது பழக்கமாகுது, பழக்கம் வழக்கமாகுது, வழக்கம் பாரம்பரியமாகுது, பாரம்பரியம் கலாச்சாரமாகுது. So, there is something to do with need. தண்ணி எடுக்கிறதுக்கு குடத்துக்கு போகிறோம், அதை டெய்லி போகிறோம், டெய்லி யாரோ பார்க்குறாங்க, டெய்லி நம்மளும் அதை செய்கிறோம், அது ஒரு டைமில் அது ப்ராக்டிஸ் ஆகிடுது. அதை அதுக்கப்புறம் ரிச்சுவலாக கொண்டாடுறோம் வருஷத்தில் ஒரு வாட்டி. ஓ இன்னாரு இதை இந்த டைமில் அது ஒரு பாரம்பரியமாக வருஷத்துக்கு வருஷம் கொண்டாடுறாங்க அப்படின்னு அந்த ரிச்சுவலும் இதுவும் ட்ரெடிஷனாக மாறிடுது. ட்ரெடிஷன் தான் லேட்டஸ்ட் ஸ்டேஜஸில் கல்ச்சராகவும் சிவிலைசேஷனாகவும் வெவ்வேறு ஆஸ்பெக்ட்ஸில் அது உருமாறி வருது. ஹெரிட்டேஜ்னால் ரெண்டு, கண்ணுக்கு தெரியறது, கண்ணுக்கு தெரியாதது. Whatever that is has a physical form, that is tangible heritage. அதை செய்யறதுக்கான அறிவு, திறன், நாலேஜ் சிஸ்டம் எதெல்லாம் பார்க்க முடியாதோ, எது வேற ஒரு வழியாக மேனிஃபெஸ்ட் பண்ணுமோ அதெல்லாம் இன்டான்ஜிபிள் ஹெரிட்டேஜ். நெக்ஸ்ட், இது பில்ட் கல்ச்சுரல் ஹெரிட்டேஜ். இது ஏர்லி சோலா டெம்பிள், வேப்பத்தூர் அப்படிங்கிற ஒரு இடத்துல இன்னைக்கு இந்த டெம்பிள் இஸ் பீன் ரெனோவேட்டட் பை ரீச் ஃபவுண்டேஷன் அண்ட் இட் ஹேஸ் அ வெரி டிஃப்ரெண்ட் ஃபார்ம் நவ். இந்த இமேஜ், இந்த டீட்டெயிலில் இந்த ஃபோட்டோ தவிர வேறு கிடையாது. இந்த கோயில் இன்னைக்கு போய் பார்த்தீங்கன்னா இப்படி இருந்துச்சா அப்படின்னு சொல்கிறதுக்கு ஒன்லி ஃபோட்டோ அவைலபிள், திஸ் ஃபோட்டோ. Why? Nobody documented. As simple as that. We didn't care to go and record something and keep it safe. So, when we lose something, it is gone forever. Fortunately, I was accompanying Dr. Kodavayal Balu on his expedition and I had a camera with me and I took some photographs. And still, I am able to have that. In the photo, scale பண்ணி அதில் இருக்கிற பிரிக்ஸோட சைஸஸ் என்ன, பிரிக்ஸோடைய மார்டர் கேப் என்ன, அது பார்க்குற அளவுக்கு நான் விதவிதமான ஃபோட்டோ எடுத்து வச்சுருக்கேன். இது நான் எப்போ எடுத்தேன் நீங்கள் சொல்லுங்கப்பா? That was before my college. Before I did my architecture, I accompanied him when I was in my 11th standard. I was interested in culture in any way. I was taking photographs, I was drawing, I was sketching, I was roaming around, collecting information without knowing whether it is going to be helping or not. That was my passion, as simple as that. Next photo. This is Mr. Venkatachalam from Kumbakonam. He is the person along with his brother Umapati Acharya, third generation Vishwakarma people, who have the knowledge and experience and skill set of doing this kind of embossing technique. What he holds is the lost wax technique. The same lost wax technique which they use for Swami Malai Chola bronzes, the same methodology he uses to do these types of small embossed works. Now his sons, daughters, nobody has learnt it. There is no one to succeed him. So where is the record? We know that this existed. Where is this knowledge? Where is this wisdom going? Have we recorded? Have we taken any photograph or video or recordings? Nothing. So this is lost forever. As long as they are alive, yes. But once they are no more, I think the art goes to the grave with them. This is Pavalakali, Pachakali and Pavalakali. It's a festival that happens in the night, late night in Tanjavur. It is a very ceremonial, very ritualistic, highly powerful, energized performance, which is part of the people's festival. So to understand the place, if you go to the place, the West Main Street or North Main Street or South Main Street in the daytime, you will never experience this aura. You will never experience this environment. So a place needs to be seen in all the times, in the night and the day, and how it is being utilized. இதெல்லாம் எதுக்கு சொல்ல வரேன்? built cultural heritage இங்கிறது people இல்லாம கிடையாது. People, அதாவது நம்மளுடைய தாக்கம் இல்லாம buildings க்கு உயிர் இல்லை. Buildings are not alive without our interventions.